24? Oh, so they give you 2 points. -2, -5. 6, -5. I guess the weird thing about this is, if you do the slope, can you see what's going to happen here? How much do the y's change? Not at all. And then the x's do something. Who cares what the x's do? Because if the y's don't change, the rise is... If the y's don't change, it didn't rise at all. It rose 0. 0 over who cares is 0. The slope is going to be 0. These 2 points are right across from each other. 6, -5, and -2, -5. So the slope is 0. Right? And if you don't believe me, you can just plug it in the calculator and the formula, slope is 0. So you can be really smart about it. If I'm at 6, -5, and 2, -5, what's the y-intercept going to be? 0, -5. It's going to have to go through that, or not, or you can just plug stuff into this guy, right? You can plug in either point you want, plug it in there. Is that cool? So the 0 part, what's that do? It just kills this whole side. 0 times who cares is 0. So then it's y minus -5. So you get that flat line. A flat line would be y equals something. Because the slope of 0 kills the x's. I like it. Maybe. So there's shortcuts depending on how much you can kind of think ahead, or there's just do the process like always and it'll still come out in the end. Yeah. Okay, cool. Anything else from homework stuff? Yes?
Page 260, question 51.
I'm sorry, 216?
Yeah.
Oh, yeah, so this is that problem with the income and the happiness. The income and the happiness by country. And the points are kind of really spread out. So whenever the points are kind of spread out quite a bit, what would R have to be? Close to 0. Right? Or closer to 0. So this one, if I said the points are kind of really spread out, could the R be 0.8? Does that make sense? R of 0.8 would mean the points are pretty decently tight to the line. They're not too far away from the line because it's close to 1. 1 would be perfectly lining up. 0.8 is a little bit away. And then if it's really spread out, it's going to be closer to 0. Because what does R equals 0 mean? What does R equals 0 mean? What does R mean?
Correlation.
What does 0 mean? I don't know.
Where are we?
Oh shit. What is R equal to 1? You all missed your break. Too bad. Hopefully you took a break earlier.
It's in a straight line.
What kind of straight line? Positive. Yeah, positive slope. You make these points big and then bam. So every point lies right on the line, R equals 1. So if it was R equal to 0.9, I would just pull the points away from the line a little bit. Maybe that's 0.9. 0.8, a little bit further away, right? But so if I had something that looked like this, that's not 0.8, right? But it is positive. Good, but it ain't 0.8. Do you guys see that? That's basically what it looks like in that problem, sort of. So the question is true or false? The R value is 0.8. False. There's just too spread out from the line that would match it. That would be the averaging point. It's too spread out from that line. Okay, maybe. So could R be negative 0.3? What did we just say? R's got to be positive. So could it be negative 0.3? Hell no. The 0.3 sounded better, but the negative part said no way. I like it. Is that cool? Yes. Okay. All right. Let's get back into chapter 4. So hopefully, the first part we did, we talked about like degree of a polynomial. We talked about combining like terms a bit. So how would I do this? Let's do this first. Let's say like it. Coolness. So combining these two polynomials. What do you have to be careful about here? Two kind of things you got to be careful about. Yeah, I got to distribute that negative, right? Because it's net minus this whole damn thing. I want to be able to put what together? What could eventually go together? Like terms, like my x squares, I want to be able to put them together, but right now they're stuck inside these stupid parentheses, right? What's in front of these parentheses? 1, so I can just take them away. 1 times that, 1 times that, 1 times that. What about negative times this is negative 2x squared. Negative times this. Negative times this. And now I can just put my like terms together. Please, dear God, if there's a minus sign here, don't start multiplying stuff. That doesn't make any damn sense. It's saying subtract. It ain't saying multiply. That's where people take forever to do the problem. Now, you made your test too long. No, I didn't. You chose to do weird shit for that problem. It just said subtract, which means put my like terms together. So what do I get for my x squares? 2x squared. What do I get for my x's? Good, minus 14x. What do I get for my numbers? Plus 3. Just put your like terms. And be really careful. That stays squared, right? Because I have 4 of these, minus 2 of these is 2 of these. It doesn't become to the 4th power or something crazy. What's the only time exponents will change? What are exponents based on? What operation are they based on? Exponents. What operation are they based on? Multiplication. So they will only change when you are multiplying or dividing, right? Here I didn't do that. I'm adding, subtracting. They're going to stay the same. I'm just going to collect those things together. So if you put 4 here, I'd be like, I don't see any freaking x to the 4th. How did you get 2 of them? That's some Harry Potter shit. That was the more boring Harry Potter movie. People missed that. There it is. Learn all the terms. Okay. So, building my way up to multiplication of polynomials. Right? How would you do this here? What do you do?
Multiply the
Yeah.
4x, then 4.
Yeah, so we know the distributive property. We just used it a second ago. So that's all this is. It's just got a little more to it than we're used to. So we take this whole thing and we multiply it in. So how do we multiply this times this? 24. X to the third. Y to the second. Kick ass. Minus, and then you take this guy to him. 8 x cubed y. You guys with me? I mean, this is not a big deal. You multiply the numbers, and then you just combine the variables, right? You add the powers when you multiply like bases. And then finally you get plus 20 x squared. I got no more x's, but I got one more y, so y squared. if you had no like terms here, they must still not be like terms now because I gave each of them the same things. If they're not like to begin with, and I give them each the same thing, they're still not like. So there's not a damn thing you can put together here. Please, dear God. I do always have somebody that's able to put these together, and that's beyond me. Like, teach me. So there's no like terms here. Going to stop. I got no more x cubed y squares. I got no more x cubed y's. I got no more x squared y squared. I got none of those. I'm done. So I'm going to show you the reason why this next thing works. And anytime I do that, I'm going to do some weird stuff that you never want to do. Right? I do this often with you guys. I show you why something works, and I say, now we understand why it works. Don't do all this weird shit, just do the shortcut that we figured out. Right? I don't know if I told you that I hate the fact that we teach you guys FOIL. But I'm still going to reference it because some of you guys know what I mean when I say FOIL instead of putting away potatoes or something. Right? Not aluminum foil. Right? Well, let me do this. Derivation of, it's spelled, Jeff, maybe? FOIL method. There you go. So if I have this problem, alright, so I know probably quite a few of you know how to do this. You might have never seen why it works. There should be a party that's kind of like, why the shit do we do that? And the other party's like, just shut up and do it. But listen to the part of you that goes, why the shit do we do that? If I had this, if I had 7 times x minus 2, what would I do? Take that number times x, and then that number times negative 2. Is that cool? Of course we would. So I'm going to take that number, because what is x plus 5? A number that I don't know yet. I'm going to multiply by the x. Is that cool? Same thing we do here. If it was 7, it would be 7x. It's x plus 5, so it's x plus 5 times x. And then I'm going to multiply by the negative 2. You could actually do it this way if you want to, but this is definitely different. And just to remind you guys, I can see in your eyes, you're all like, God, why does this guy want us to do it? I don't want you to do it this way. I'm trying to show you why the way we do it works. And what do you get here? Now this is just distribution, right? Distribution. So you get x squared plus 5x, and then distribution. Minus 2x, minus 10. So then you get x squared plus 3x minus 10. Right? So then we develop a shortcut. We say, look what I did. I actually took the x times x and the x times negative 2, the 5 times x and the 5 times negative 2. That's what happened here, right? So that's the way we do it, and we use the word FOIL foolishly, I think. We don't really need it. And if you know FOIL and you love FOIL, that's good. But you don't need it. It's like a mnemonic device to remember first, outer, inner, last. Personally, I think it just makes it more complicated. Because what do you really do? Screw FOIL. You take this guy and you distribute him. And then you take this guy and you distribute him. That's it. You don't need FOIL. You just, what are you distributing? Both of these things. So you do that. I like it. So here, you guys try this. If you like FOIL and you use FOIL, continue to do so. I'm not trying to take it away from you. But the next level up, you can't use FOIL. So I almost wish they just didn't teach it. Alright, so do that one. take the y through, right? What's y times y? Y squared. What's y times 9? 9y. Then you get this guy a turn. It's my turn. Negative 4 times y. Negative 4 times 9. And then you just put together whatever like terms you have. Sometimes there won't be like terms. If I made those letters different, there won't be like terms. So then I get y squared plus 5y minus 36. Real quick side note. What is y? An answer could be, I don't freaking know. But what does it represent? A number, I don't know yet, right? So it's got to act like any number. In fact, since it can be any number, let's say, what if y is 6? Go with me for a second. I'm about to do shit that you would never have to do yourself. But it actually is a way to check this. And we're going to use it when we do the backwards thing, when we factor to start here and go there. We could do something similar. If y was 6, what number is this? 2. Is that cool? And what number is this? 15. And twice 15 is? 30. So if we did everything right, when I make y 6, this better come out to be freaking 30. Because we're claiming that that is the same as that. So if y is 6, what do I get here? 36
Plus 30.
plus 30
Minus 36.
minus 36. I get 30. So any number you pick, that would work. Because that is that. Does that make a little bit of sense? A little bit. So you actually have a way to check these if you have time. You just pick a number. If that number comes out the same as this one, that looks good. What sucks is if you mess up when you're plugging a number in and you think you got it wrong. When you got it right, that sucks. You got to be careful. So here's where FOIL lets us down. Because you can see right here, first, outer, inner, last, ooh, right? I just like to think of it as repeated distribution. This guy gets a turn to distribute, this guy gets a turn to distribute. Because if I have something like this, FOIL ain't gonna do shit for me. Right? It'd have to be I don't know what the freak is, right? First middle, first last, outer, inner middle, what the hell? Right? Good Lord.
Oh. Back in my high school, we used this method where, the box method.
I'm with you. I'm trying to get you away from that, to be honest. But if you like it, okay. But it's a little bit better to be able to do this because what we're doing now with this idea of distribution is used more generally in higher level stuff. So the box method's nice, but it would really suck if I had to have this huge, oh my God, you need to be able to do what we're about to do right now, which is just take the 4x and multiply it through. What's 4x times 2x squared? 8. X cubed. Now do the 4x times negative 3x. Cool? You guys with me? And then do the 4x times the 2. Now one thing you can do for yourself is now this guy gets a turn, right? Negative 1 gets a turn. What's negative 1 times 2x squared? And I'm going to put it with the other x squares. You see, I can kind of line up my like terms as I go. And then negative 1 times negative 3x? Plus 3x. And then negative 1 times 2? Negative 2. And now you can just put together your like terms. And again, if you chose a number for x, you can figure out what that is, and then that's going to be the same number because those are the same thing. So why is algebra difficult? Because we just multiplied an infinite number of numbers together. I don't know if you guys realize that's what we just did. Because what could x be? An infinite number of things. So we just multiplied an infinite number of numbers together. So tell people that later. This morning I multiplied an infinite number of numbers. What did you do? I slept in. That sounds better. Well, it's still impressive. Okay. So, let me give you this. I got a little summary of stuff from section 4.1. It includes a couple questions about monomial, binomial, trinomial, and the degree, right? At the beginning. And then it goes into this stuff that we were just doing now. If you want to work together, you can.
I would have been like,
Wait a minute. Send that makeup text over towards you. Sent you an email just this morning.
This morning?
Yeah. Okay. So I figured you didn't get it yet, but
Okay.
look for that.
Yeah, I'll check it out.
I don't know you guys have